Nazario. Nika. Nazario, Nika.
Sir.
Hello?
Hello po.
Wala si Nazario. Nika, wala?
Sir, nagsabi po ng present, mahina lang po ata.
Okay. Sige.
Present po. No.
Okay, next, si Nite, Kurt Russell. Nite? Kurt Russell? Wala si Nite. Absent ba ito? Kurt Russell. Okay. Nolasco.
Present po.
Okay. Obida.
Present po, sir.
Obida. Okay. Ola. Mark Joris.
Present po, sir.
Okay. Si Organo. Organo. Sheldon. Loic. Wala si Organo. Nite. Yaban Nite. Wala si Nite.
Nag-chat po, sir, sa comment section.
Okay. Sige. Okay, si ano po? Si, ano ba to? Obida? Wala si Obida?
Hello po, sir.
Clarence?
Andito po.
Okay. Si Organo? Sheldon? Organo? Saan ba to? Okay. Okay, Pablo? Pablo Glorian? Absent?
Present po.
Okay, si Organo, Sheldon. Okay. Sheldon. Loic, Organo, absent.
Maganda po, sir. Present. Nag-chat po, sir.
Ano si Organo? Present. Nag-chat ba?
Yes po, sir, nag-chat po.
Ba't nag-chat? Ba't hindi makapag-ano? Apelido natin, Viola. Okay. So, iba hindi gumagana ng mic, no? Ano ba yon? Nasa labas sila o, di ba? Nasa ba yan? na organo tsaka ngiti. Okay, sino ba to? Okay. Pagayunan, tapos na ba ako pagbitan?
Present
Bita.
po.
Okay. Si Pantonyal, Junel.
Present po.
Okay, Paraino.
Present po.
Okay, si Rait, Daniel.
Present po.
Okay, Ranis, Desiree May.
Present po.
Okay, Reyes, Trisha. Ito, Jan Red. Oh, Jan Red, ba't ngayon ka lang pumasok? Reyes. Reyes.
Lang po ng problem po sa schedule po.
Bakit nagkaroon ka ng problema sa schedule?
Working student po. Minsan po hindi ko na po naabutan yung sa class po.
Oh, diba? So, dalawang ano yun, subject yun. Pwede nakitang i-drop. Ano, tapos na tayo ngayon eh, itong klase na to. Reyes. Ang last na yung huli mong pasok is yung November 12 pa. 2022. Tapos hindi ka na nagparamdam. Okay? Ito yan, ha? Ulitin ko, class, no? Kung nahihirapan kayo, no? Yan yung sinasabi ko noong 1995 ba, hindi pa kayo panganak, no? Estudyante ko, no? Kung sakaling nahihirapan kayo, no? Balansihin yung trabaho at yung pag-aaral, mamili kayo. Okay? Mamili kayo. Kung trabaho o pag-aaral. Kasi hindi po pwedeng mapabayaan nyo kasi hindi ko kayo papasa. Unang-una, ano kayo ha? Scholar kayo, class ha? Okay? Wala kayong masyadong gagastusin. Kung nasa private school kayo, mga 50,000 ang bayad niyo. Okay? Yung private school yan. Depende kung ano school yan. Petilia. Since IT kayo, halimbawa, De La Salle, no? Mapua, okay? Adamson, UST, FEU, UE, yan. Pero scholar kayo class eh. Kasi iba, ginagawang dahilan yung trabaho. Okay? Unang-una, wala kang proper coordination. Okay? So, yun po, no? So, medyo delikado ka, Reyes, ha? Ganito, ha? Ulitin ko, yung mga second year. Ngayon, tama, second year kayo? President, tama ba, Mr. Nana? Di ba? Carlo, CR, no? Si Carlo Rafael. Okay, ulitin ko, kaya yung binagay ko kanina, no? Kapag kayo ay bumaksak sa akin, itong subject na to, operating system, okay? Aabutan kayo ng new curriculum. Ang nasa likod nyo lang, new curriculum, kayo old curriculum. Okay? Tatamaan kayo. Pag tinamaan kayo at bago ang subject code ng operating system at description, subject description, no? Mag-new curriculum kayo. Okay? New curriculum. So, by 2024 kayo. Okay? Maaaring mag-first year uli kayo. Wala nang problema. Bata pa naman kayo. Okay? Dito kayo tatanda. Okay? Sige. Kasi kahit na marami akong estudyante nagtatrabaho, pamilyado pa nga eh. Pero hindi na papabayaan yung pag-aaral. Okay? Sige. Petilia. Pato, Tejada. So kasi unfair doon sa mga pumapasok, no? Na pumapasok na may trabaho rin pero hindi na pababayaan yung pag-aaral. Hindi excuse yun, ha? Pati yung mga, halimbawa, sinasabi sa sir, ano pa ako, Dean's Lister, President Lister. So, ano ngayon, kung President Lister ka or Dean's Lister, hindi naman badge yun, no? Para ipasa ka. Pinaghihirapan yun. Pinaghihirapan nyo. Hindi hinihingi. Okay? Sige. Sige ba hindi ko natawag? Casey Rodriguez, Catherine. Diyan po ba?
Present po, sir.
Okay. Rosales, Ira, Ismael. Wala si Rosales. Nasa labas. Okay. Wala ba? Rosales, last call. Nasa Rosales. Rosales, ano to? Ira. Tanya. Rosales, Ira. Ba to sis Ira? Na-overlook ko to. Okay. Wala. Doble. Okay. Sige. Wala si Ira, no? Kapule. Absent. Okay, next si Takwel. Andiyan ba si Takwel?
Present po.
Okay, Tejada. Andiyan po ba?
Yes, sir.
Okay, Tiamzon.
Present po, sir.
Okay, si Yanya. Peter, John, Nino. Peter, Yanya. John, Nino. Wala, si Tanya. John, Nino, Peter.
No po, sir. Sorry po. Medyo
Okay.
nag-lag po. Present po.
Okay, Tolosa, Junior.
Present po.
Okay, Topacio. Topacio, Nisha.
Present po.
Okay,
Present.
Basalio. John. Ludwig. Basalio.
Hello? Present po.
Bente. Mark Benzer.
Nandito po, sir. Present po.
Okay. Ventosilio. Renz J. Elbano.
Present po, sir.
Okay. Villacampa. Mark Jason.
Present, sir.
Okay. Villena Victor.
Present po.
Okay. Si Viola.
Present
Sige.
po, present po.
Okay. Si Yang. Andiyan ba si Yang? Ken David. Okay. Meron ba hindi natawag? Okay. Ang absent si Abog. Okay. Santos ba? Teka lang. QRS. Ayun, Santos Kapuli. Hindi ka sumagot kanina. Kaya absent ka. Tinawag kita. Okay, tinanggal kita dito. Okay? Sige. Meron pa ba hindi natawag? Okay, absent po si Montebon, no? Sino pa to? Okay, perfect attendance ang 100 po sa class standing. So, ito, sa attendance, okay? Panghulan, absent. And sino to? Si Villaduna, absent. Si Vinyosilio Rom, absent. And Yabot, absent. Okay? So, 6 absent, 38 ang present. Okay. Okay, class, no? Today I'm going to discuss about the page memory management, no? So, pag sinabi natin page memory management, no? Ibig sabihin nito, you put, no, more burden, kumbaga, on the operating system to keep track, no, of allocated memory, no, and to resolve addresses. But ang benefits nito gained by this approach, no, are generally worth, no, na the extra effort. Now, pagdating po in page memory technique, no, yung main memory is divided into small fixed, no, size blocks, no, fixed size blocks, okay? Ang tawag dito frames, no, fixed blocks of storage called frames, okay? So, now, a process is divided into pages, no, that, no, for the sake of our discussion, we assume yung same size as a frame, ganun, no, the same size, no, as frame, okay? So, when a program is to be executed, no, example, no, now the page of the process are allocated into various unused frames distributed through memory. Okay? Kasi meron tayong main primary and secondary, no, memory. Okay? Now, so the pages of a process may be scattered around, no, out of order, kumbaga, no, and mixed among the pages of the other processes. Now, to keep track of all this, the operating system maintains, no, itong trabaho niya, maintains a separate page, no, tinatawag natin PMT, no, yung page map table o PMT. Okay? For each process in memory. So it maps each page to the frame in which it is loaded. Okay? Now, you can see in this figure or slide, no, note that both pages and frames are numbered starting with 0, no, which makes the address calculation easier. Kaya meron tayong page 0, 1, 2, 3, 4. Right? So, a logical address is a page memory. Ulitin ko, a logical address is in a page memory managed system consists of two, no, values. Ano to? A page and an offset. Okay? Ulitin ko, a logical address in a page memory management system consists of two values. Ano to? Ito yung tinatawag na page and an offset. Okay? Now, a logical address kadalasan, no, written as, no, greater than, nakasandwich siya ng greater than or less than, no, symbol, no, na sign, no, page, comma, offset. Okay, ganun po, no. Pag, kumbaga, sa ating coordinates, merong close and open parenthesis, x, comma, y. Tama ba yun? Kung natatandaan nyo yung inyong geometry, no. So, pagdating sa logical address, no, ulitin ko, nakasandwich siya ng less than and greater than symbol. Na nasa loob nun is yung page separated by a comma and offset. Okay? So, yung offset, numerical po to. Page and offset, numerical po to. Separated by a comma. Example, no? Yung, halimbawa, greater than and less than, no? Naka-sandwich yung greater than and less than yung 2, 518. Ano ibig sabihin nito? Which means that the reference is to 518 bytes. Okay? Ano yun? Yun yung offset into page 2. Yung 2, no? Page 2 yon, no, of the process. Okay? Now, to produce naman a physical address, no, you first look up the page in the PMT, no, in page map, no, table, to find the frame number in which it is stored. Then multiply the frame number by what? By the frame size. No? And add, no? Ibig sabihin, i-add mo, ipa-plus mo yung offset para makuha natin tinatawag natin physical address. Okay? So, yun po, no? So, for example, no? Halimbawa, in a situation dito sa figure dato, given the situation shown in this slide or figure, no? If process 1 is active, a logical address, halimbawa dito, no, is 1, 222. Okay? So, ang ating one dito is your page, no, separated by comma. Ang maging offset natin halimbawa is 222. Okay? So mangyayari niyan, mapaprocess siya as follows, no, in page 1 of process 1 in this frame 12, you know, kita yung 12, ayan. Ang frame 12 nasaan po? Okay? And frame 12 nasa memory yung 1 2 3 nasa memory, no? Frame 12. So page 1 slash page P1 process 1 slash page 1. Okay? Now, so, ibulitin ko, yung page 1 natin, ang process niya 1, ang frame niya 12. Therefore, the corresponding physical address, gagawin natin dyan is 12 multiply by 1024, no? Bytes. Okay? So ibig sabihin yan, kung alam niyo yung kaya discuss ko sa inyo yung number system, yung 1, 2, 4, 8, 16, 32, 64, 128, 256, 500, 1024. So multiply natin in 12, ang 12 natin is your frame, no? 12 times your frame, 12 yung ating frame, multiply by frame size. Ang frame size natin, for example, is 1024. Then you add yung offset. Halimbawa, ang offset niya is 222. So therefore, magiging 1,000, 12,000, no? 12,510. Okay? So frame number, again, frame number multiplied by frame size plus offset is equal to physical address. Okay? Okay, so note, no, that there are two ways in which logical address could be invalid. So, okay, so ano po ba yun? The page number could be out of bounds for the process, or maaaring maging invalid yung logical address niya kapag yung offset niya could be larger than the size of a frame. Okay? So, yun po. Okay? Now, so the unpad, when it comes to paging, no, page memory management, okay, the advantage of paging is that yung process no longer needs to be stored, no, continuously in memory. So ang ability nito is to divide a process into pieces changes, no, the challenges in loading process from finding one available large chunk of space to finding enough small chunks. Ito more on theory to, no, pero kung mapapansin nyo, saan to? Ito yung tinatawag nating registry, no? Mamaya di-discuss ko sa inyo yan, no? So ito yung sa subject na digital logic and switching theory. Okay? So, an important extension to the idea of page memory management class is the idea of demand paging. Okay? Pag sinabi natin demand paging, demand paging, which takes advantage of the fact that not all parts of a program actually have to be in memory at the same time. Okay? So at any given instance class in time, yung ating processor or the CPU in accessing one page of a process, at that point, it doesn't really matter if the other page of a process are even in memory. Wait lang po. Okay, so the act of bringing in a page from secondary memory, ano ba yung tinatawag natin secondary memory class? Hello, class? Yung dun sa computer hardware servicing. Na-discuss ba sa inyo yung class? Hello? Ano boses?
Mga hard drives po.
Ano yung, ano yung tinatawag na primary memory? At secondary memory. Okay, RAM. No, last ko. Ano yung RAM? Primary, secondary?
Primary siya.
Primary ba yun? Di ba? Ano ba tinatawag ng volatile and non-volatile? Alin yung memory kapag na-turn off mo, na-refresh siya? Once na-reboot. No? We have two types of booting, no? Cold booting, warm booting. Di ba? Pagka nagkaroon ka ng configuration, no? They suggest that na kapag nag-changes ka ng configuration or nag-install ka ng software or nag-uninstall, di ba? Nire-restart mo yung program o yung system o system restart o tinatawag natin warm booting. So, ano nangyayari sa memory? Hello, class. Wala ba mga kasiwat, class? Ano ba yung RAM plus tinatawag? Random access memory. At meron tayong tinatawag na ROM. Yung ROM, di ba, yung ano, kung nasa motherboard, ito yung yung nasa BIOS setup, CMOS. At yung ating sinasabi yung secondary, ang primary memory nyo, di ba? Ang primary, ano to? Either lang po sa storage memory random access. Ano ba yan? Either. Okay, sabi ni John, no? Michael Nolasco, either RAM lang po or storage memory, random access memory po kasi pang temporary yon, temporary storage, no? Disposable, disposable ba siya? Na ginagamit po ng CPU, di ba? So once, di ba, na-restart yan, di ba, nabubura lahat doon. That's why sinisave natin sa primary memory. Saan yan? Saan hindi nabubura, class? Sa RAM o sa hard drive?
Sa hard drive po.
So, yun. Okay? So, yun po. Okay? So, yun po ha. Dapat alam niyo yung tinatawag nating secondary and primary memory po. Okay? Again, meron tayong tinatawag class na na yung the act of bringing a page from secondary memory, no? Which kadalasan causes another page rather, to be written back to secondary memory. Ang tawag dito page swap. Okay? Meron din tayo tinatawag na demand, no, paging, no? It is an extension, no, of a page memory management in which yung pages are brought into memory, no, only when reference, no, o tinatawag natin on demand. Okay, now in page swap, ito naman ay bringing in one page from secondary memory, possibly, no, causing another to remove. Okay, so meron din tayo, no, yung sa demand paging approach, no, gives rise to the idea of tinatawag nating virtual memory. Okay? Kasi virtual memory, no, ito yung illusion, no, is the illusion, no, that there is no restriction of a program size. So madalas ginagawa to noon, no, yung virtual memory, lalo yung araw, no, yung mga 90s, no. So akala mo may hard drive, drive C, pero virtual memory lang yun, no, ginagamit. Okay? So the illusion that there are no restriction again at the size of the program. Bakit, no? Because the entire program is not, kumbaga, necessary in memory at the same time anyway, no? So may tinatawag din tayong crashing, no? Okay? Okay. Trashing, inefficient, no, processing caused by constant page swapping. Okay? So, pag too much page swapping, ang tawag dito, trashing, and can seriously degrade yung system performance mo. Okay? So, yan po, no? Again, yung pagdating naman po sa process management, okay, another important, no, resource that an operating system, no, must manage, no, is the use of the CPU or processor or microprocessor by individual processes. Okay? Now, pagdating naman sa process states, the process moves through through specific states, no, as they are managed in a computer system. Okay? Now, a process enters the system, okay, in ready to be executed, meaning is executing or waiting for a resource or finished. Okay? So, the process state, no, now in this figure or slide, okay, na pinapakita dito, each oval, no, represents a state, a process might be in using yung no, arrows indicate how and why a process might move, no, from one state to another. So let's examine, no, what is happening to the process in each state, no, class. So in the new state dito, makikita nyo dito sa rectangular na shape, okay, in a new state, a process is being created. An application process created when a user submits, no, a program. Ano ito? For what? For execution. Or a system process created by operating system to accomplish, no, a specific task. No? A specific task rather. Okay? Now, a process that has barriers to its execution is in ready state yan. Okay? Now, kapag ang process is in ready state, is not waiting for an event occur kumbaga for data be brought into in from secondary memory. Okay, so it's waiting only for its chance to use by kumbaga yung ating processor. Okay, now a process naman in running state, okay, ito naman is currently being executed by the microprocessor or yung CPU. So yung maging instruction are being processed and kumbaga in the fetch executed cycle, a process in the waiting state is currently waiting for the resource, kumbaga other than the microprocessor. Okay, now mateterminate lang yung state has been completed. Okay, its execution and it's no longer an active process. At this point, plus yung ating operating system no longer, kumbaga hindi na kailangan niya i-maintain yung mga information regarding the process. Okay? Now, process may be ready state o kaya naman waiting state at the same time. Pero isa lang dapat ang mapaprocess. Kumbaga, ano yun? Ito yung running state. Okay? So, after a process naman is created, yung operating system admits it to the ready state. Okay? Meron tayo tinatawag plus algorithm. Ano ba tinatawag na algorithm? Kasi when the ating processor or CPU scheduling algorithm minsan dictates a process is dispatched to the running state. While running, the process might be interrupted by the operating system para kumbaga mabigyan pagkakataon para ng isang CPU. Okay? Ano ba yung tinatawag na algorithm class? Anyone? Ano tinatawag natin algorithm? What do you mean by an algorithm?
Rules?
Hello? Rules? Ano pa? Aside from Mr. John, di ba algorithm is a
Systematic
sequence,
process.
tama ba?
Process.
Parang, is a a process, okay. Okay, very good, Algorithm is a sequence of instructions, that tells, how to solve a particular problem. Tama ba yan? Yun ang algorithm, okay? So, in that case, class, the process simply returns to ready state, okay? Or, a running process might request a resource, that's not available, o kaya, require an input-output to what? To retrieve a newly referenced part of a process, okay? So, in which case, it is moved to the waiting state. Okay? Okay, so, meron tayong tinatawag na PCB, yung process control block. Okay? Plus, yung ating operating system, kumbaga, dapat ma-manage din niya yung large amount of data for each active process. Okay? The data is stored in a data structure. Again, ulitin ko, the data is stored in a data structure. Ang tawag dito ay PCB, Process Control Block. Generally, kumbaga, each state is represented by a list of PCB or Process Control Blocks. Okay? When a process moves from one state to another, its corresponding PCB or Process Control Block is moved from one state list to another pagdating sa operating system. Okay? Now, a new PCB or process control block is created when a process is first created. The new state, kung tawag natin dito, and it's kept around until the process terminates. Okay? So, plus, yung may tinatawag tayong register, importante rin to. Ito yung is a collection, collection to ng flip-flops. Yung flip-flops class, kailangan kasi mapag-aralan mo mga logic symbols class o logic gates class.
Yes po, napag-ano po yung logic gates.
Okay, very good. Na-discuss din sa inyo yung flip-flops, mga multiplexers.
Hindi po,
Ganun, class.
sir.
Okay? So pagdating sa register, no? Again, is a collection of flip-flops, no? Used to what? To store a group of binary digits. No? Yan ang trabaho niyan, no? To store a group of binary digits. Di ba alam niyan? Diniscuss natin kanina sa datacoms, yung binary digits. Yung tawagin natin bits. Okay? While a computer is processing them, no? So, ito yung tinatawag din natin computer architecture. Pag sinabi natin computer architecture, ito yung design and internal structure ng isang digital computers. Okay? So, ito importante dito, no? Kaya dapat pagdating sa register, no? Pag-aralan niyo muna yung mga gates, no? So, ang gate, for example, two inputs, no? Two or more inputs and one possible output. Na-recall niyo ba yung ganon? Na-review ba yung ganon? Yung two inputs and one possible output. For example, yung AND gate, na-discuss niyo yung AND gate or gate.
Yes po,
Ano ba yun? NOT gate,
or
tama?
Opo.
Exclusive OR gate, exclusive NOR gate, tama? Yon, na? So, yun po, importante yun, huwag yung kakalimutan yon. Kasi ang flip-flops is a combination of parang, ano yun four gates, no? Okay? Meron siyang two or more inputs and one possible output. Okay? So, doon dinidiscuss siya sa logic series and switching theory. Kasi, ang example ng register class, pagdating sa basic electronics yun, kung na-discuss sa inyo yung semiconductor, ano yung semiconductor? Na-discuss ba sa yung mga semiconductor components sa basic electronics yung class? Example ng semiconductor component is a diode. Nakita nyo na ba yung diode? O mas, para maging specific, yung rectifier diode class, it is a semiconductor component. Okay, polarized po siya. Ibig sabihin, pag polarized, may positive, negative. Why? Bakit may positive, negative? Dahil meron siyang anode and cathode. Ang pag nagpapaseparate sa anode and cathode, in junction. So, yon. Pag forward bias, binary 1. Pag reverse bias, binary 0. Bakit, sir? Kasi nabablock niya yung current. No? Pag forward bias, no? On yon. On state yon. Active high, binary 1. So, nag-a-act yung register ganun po. Kasi ang semiconductor, to guys sa mga, pag nagsisave ka, parang dito sa microprocessor. Ano yung microprocessor o CPU? Composed of billions of transistors. Okay? Nakita na ba kayong transistor? Na-discuss mo sa iyo yung two types of transistor, NPN and PNP, positive, negative, positive, negative, positive, negative. Na-discuss sa iyo yan. Meron tayong emitter-based collector. Class. Hello.
Medyo limot na po, sir.
So,
Na-discuss.
yun po yun, ha? Kasi, okay, ito yung subject ng, ng ating, ito sa operating system and CPU processor. More on theory ito. Pero kapag ito pinag-aral actual to, no? Semiconductor to. Kasi ang diode class, tandaan nyo, na-discuss yung power supply. Ay, ganito lang. Kung hindi naman na-discuss nyo, ganito, mabilis lang tayo. Di ba meron kayong charger? Correct? Sa bahay para sa cellphone nyo. Kasi ang cellphone nyo, low voltage yan. Kaya direct current. Okay? Mabilis lang to. Okay, so yung alternating current, high voltage yan. Okay? High voltage. Okay? Kaya ini-step down yan. Okay? Kasi kapag hindi na-step down yan, pwede sunugin ang electronic components. Kasi ang high voltage para lang design para sa electric fan, motor, sa motor, yung mga for example, yung mga compressor, aircon, no? Ang television nyo, no, kino-convert yan. Kaya may transformer yan sa loob. Ang trabaho yung step down, yung ibig sabihin from 220 to multiple, no, output. Pwede siyang, kaya sa power supply, no, meron tayong multi-tap na tinatawag na from 0, 3 volts, 4, di ba may ganon, may selector switch, 4 volts, 4.5, 6, 9, 12. Pero sa system unit natin, may output lang siya, no? May input na voltage na 12 at may 5. Okay? Kasi ang IC, ang input niya 5 volts. Okay? So ibig sabihin ko class, no? Kapag kung gumamit tayo ng ng diode, no? Ito yung sa register sa mga ating sa paano mag-store ng memory. Okay? So in binary digits kasi switching yan. Nag-act yung semiconductor as a switch yung diode at transistor. Ang diode kasi used to convert alternating current to direct current. Kaya pag pumasok na yan dyan, mula doon sa sinaksak mo, plug in mo doon sa convenience outlet sa bahay ninyo, and then ipa-plug in nyo, i-insert nyo sa port ng inyong, regardless kung anong type ng, ng USB yan, port. Okay? Once na i-plug in yan, okay, ang lalabas doon, papasok sa cellphone nyo, low voltage, direct current, pure DC. Actually, pure DC, yung mismo yung internal battery niyan eh. Okay? So, yun po. No? So, kapag nag-reverse bias po yan, kaya nako-convert yung AC to DC dahil sa diode. Ngayon, ang diode hindi lang sa pagko-convert. Okay? Ginagamit din yan for what? For memory. So, ang tawag yun, transistor. Kaya may processor, a microprocessor composed of billions of transistor. Nag-a-act yan as a switch. Kaya binanggit ko sa inyo kanina, pag forward and reverse. Pag forward, ibig sabihin, may current ng flow. Ibig sabihin, binary 1. On. Okay? So, pagka nag-reverse bias, active low means off. Bakit? Nabablock ang current. Pag nag-reverse bias yan, no? Nagiging ang tawag yan, dielectric material. Pag naging dielectric material, ibig sabihin, hindi siya nagkakandak ng electricity. Bakit po? High resistance siya. Example ng mga high resistance yung wood, plastic, air, diba? Rubber, okay, glass, yan po ang mga example. Okay? So, ganun po So, nagsiswitch yan, 10, 10, 10. Ganun din sa flash drive nyo. Okay? Ganun din sa flash drive nyo. Gumagamit ang register. Okay? Now, yun po. Next. Okay. Yan po, no? So, yun po, no? Saan na ba tayo? So again, no? So each time the process is moved to the running state, the register values for the current running process are stored into its PCB. Okay? Ngayon, ang register values of the new running state are loaded into the processor or microprocessor. So, itong tinatawag na exchange of information, no? Register to CPU, mga ganun, no? Ang tawag dito is a context switch. Kaya nga nag-act siya as a switch, no? Yung transistor. Okay, CPU scheduling. Okay? So, CPU scheduling, wait lang po. Hindi lang ako tuloy po. Mabalik lang tayo sa transistor class, no? Maintindihan yung sinasabi ko. Kapag nakita na kayo ng diode, no? Na-discuss ba sa inyo yung diode class? Kasi mahirap magpaliwanag ng ano eh. No? Kaya mas maganda talaga pagdating sa actual na next, no? Kung bibigyan ako ng subject ni Ma'am Dela Isla ng basic electronics, no? Dapat doon na tayo, doon sa ano eh, doon sa school mismo, no? At least may tuturo ko pa paano i-troubleshoot, i-test using an ohmmeter. Kasi ohmmeter paggamit dyan eh, no? So, pag ohmmeter, ibig sabihin, resistance test ang natin, R times 1 to R times 10. Depende, no? Depende sa electronic components. Okay? Doon mo lang malalaman kung reverse or forward eh. Paano? Tester. Tsaka plus, meron naman siyang, ano eh, no?
Hey everyone, it's VDX.
Na stripe naman yun eh. Na white. Ibig sabihin, that's cathode side. Ang anode side, yung purely black. Okay? So, hindi ka maliligaw. Huwag lang buburahin. Okay? Paano buburahin? Ibig sabihin, lilihain, ganun. So, yun po, na. Okay. So, CPU scheduling. Okay? CPU scheduling is the act of determining which process in the ready state should be moved to the running state. That is, no, yung CPU scheduling class algorithms decide, no, which process should be given over the processor or CPU so that it can make computational progress. Okay? Now, yung CPU scheduling decisions are made when a process switches from the running state to the waiting state, or when a program terminates. Okay? This type of CPU scheduling is called non-preemptive, no? Non-preemptive scheduling. Huh? Okay? Ulitin ko. When it comes to CPU scheduling, decisions, okay? Kapag isang process of switches from running state to the waiting state, or when a program terminates, okay, this type of CPU scheduling is called non-preemptive scheduling. Why? Because the need for a new CPU or processor process is the result of the activity of the currently executing process. Okay? CPU scheduling or processor scheduling decisions class may also be made when a process moves from the running state to the ready state. Okay? Kaya when a process moves from the waiting state to the ready state. Okay? From running state to the ready state, or when the process moves from waiting state to ready state. These are examples of preemptive scheduling. Okay? Because the currently running process is preempted by the operating system through no fault on its own. Okay? Now, in scheduling, algorithms ay kadalasang evaluated using what? Particular metrics such as turnaround time. Okay? Turnaround time for a process. What is the turnaround time? Okay? A turnaround time is a microprocessor or CPU scheduling metric that measures the elapsed time between a process arrival in the ready state and its ultimate completion. So this is the amount of time between when a process arrives in the ready state to the next to the time it exists the running state for the last time. Okay, so we would like on average for the turnaround time to our process to be small. So there are there are various approaches that can be used to determine which process gets chosen first to move from the ready state to the running state. So we will examine we will examine three of them in the ito next slide. Wait lang, unmute ko lang si Panghulan. So, meron tayong first come, first serve. Ano po ba ito? In first come, first serve, tinatawag natin FC. Okay lang po. Okay, FC, in first come, first serve or FCFS scheduling approach. Okay, process are moved to the CPU, processor, in order in which they arrive in the running state. Okay, now, in FCS, first come, first serve scheduling is non-preemptive. Okay? So, once a process is given access to the CPU, it keeps it unless it makes a request that force to wait. Okay? Such a request for a device is used by another process. Now, suppose, halimbawa, yan po, yung ating process 1 through suppose yung ating process P1, process 1 through process 5 o P5 arrive in the ready state. Okay? In first column. Okay? At essentially the same time to make our own calculation simple but in the following order and with the specified service time in the FCF scheduling, each process received access to the CPU. No? So for simplicity, we assume here, plus, no, sa ating example, that yung ating processes don't cost, no, themselves to wait, no. So the following Gantt chart, okay, so shows the order and the time process completion. Okay, so since we are assuming dito class, no, the process all arrive at the same time, so the turnaround time for each, no, process is the same as its completion, no, rather. So therefore, the average turnaround time is equal to the sum of 140 plus 215 plus 535 plus 815 plus 940. Given po yun, no? Ganun sa given, divided by 5. Okay? So therefore, the average turnaround time is 520, okay, milliseconds. Okay? Now, when it comes dun naman sa shortest job next, okay? So the shortest job next, or tinatawag nating SJN, okay? The CPU scheduling algorithms, no, looks at all processes in the ready state and dispatches the one with the small service time. Okay? So in this slide class is the Gantt chart for the same set of processes, no? We examined kumbaga in the FCS, no, FCFS, no, example. Okay? Because the selection criteria are different, the order in which the processes are scheduled and completed are different. Okay? So in this figure, okay, meron tayong given, no, na process from P1 to P4. So to solve for the average turnaround time for this example is, okay, the sum of 75 plus 200 plus 340 plus 620 plus 940 divided by 5 is equal to 435. Okay? So class, no, note that the SGN or algorithm relies on knowledge of the feature. That is, it gives the CPU to the job that runs from the shortest time when it is allowed to execute. Okay? Okay, so in round robin, okay, so the CPU scheduling distributes the processing time equitably, no, among all ready process. Okay? So the algorithm establishes a particular time slice, or tinatawag natin time quantum, which is the amount of time each process receives before being preempted and returned, no, to the ready state to allow another process its turn. Okay? So eventually class, no, the preempted process will be given another time, no, slice off on the CPU rather. So this procedures class continues until the process eventually gets all the time it needs and terminates. Okay? Now, in CPU scheduling class, no, kumbaga, is when a process moves from running state to ready state. Okay? Ulitin ko, no? And when the process moves from waiting state to ready state, these are examples of preemptive scheduling. Okay? Note, itong round-robin algorithm is a preemptive. Okay? So the expiration of a time slice is an arbitrary reason to remove a process from the CPU. Okay? So this action is represented by the transition from running state to the ready state. Okay? Sige. Okay. Suppose, no? Dito sa given natin, suppose the time slice now used for a particular round robin scheduling algorithm was 50. Okay? And we use the same set, okay? We use the same set of process as a previous, no, kaninang example natin. Now, the chart results are, ito po, no? So, each process is given a time slice of 50. Okay? Unless it doesn't need a full slice, no? For example, a process 2 originally needed, halimbawa, 75 time units, okay? 75 time units, and it was given as an initial time slice of 50. Okay? So, when it turns to use the processor, or microprocessor, or CPU, no? So, came around again, it needed only 25. So, therefore, yung ating terminates and gives up that CPU a time of 325. Okay? So, therefore, the average turnaround time for this example is the summation of 515. Ang 515 natin is yung P1. Okay? And 325 is your P2. And your 940 is for P3. And yung 640 for process number 5. Okay? Divided by 5. So therefore, the average turnaround time is 668. Okay? 668. So, mapapansin niyo class, no, yung turnaround time is higher than the other examples kanina. Okay? So, ang tanong dyan, no, does that mean that the round robin algorithm is not as good as the others? Hindi po. So, why, sir? Kasi we can't make such general claims based on one example. No, we can only say that one algorithm better than another for that specific set of process. Okay. General analysis of algorithm efficiencies is much more involved. Okay. So again, yung ating turnaround robin, okay, CPU or processor, microprocessor, or central processing unit process scheduling algorithms, no, is probably the most widely used. Excuse me. Okay, it generally supports all kinds of jobs, no, or process, and it is considered the most fair. Okay. Okay, what is a Gantt chart? A Gantt chart is a horizontal bar chart developed as a production control tool in 1917 by Henry L. Gantt, an American engineer and social scientist. Okay, class, again, class standing computation sa ating operating system subject. Midterm grade, CS is equal to 50% your quizzes, plus 50% your case study, assignment, project activities, plus, dito papasok yung inyong attendance. Ha? Okay? Plus, times 70% plus 30% of your midterm exam. Okay, your final grade, ganun din po, CS, 50% quizzes plus 50% case study, assignment, project, activities, multiplied by 70% plus 30% ng inyong final exam. Again, your final grade computation is equal to midterm grade plus final grade, divide it by 2. Okay? Okay, class. Question, class. Okay, yung ating magbibigay po ako ng self-review. Siguro within a week, siguro. Kasi matagal na ito kasi i-upload ko pa, no? And then sa Google Classroom. So magse-set po ako ng deadline, okay? So magbasa po ko tayo sa GC, ha? Magbasa po tayo sa GC yung iba, okay? Ano yung mga hindi pa pumapasok, okay? Ika lang, check ko ulit attendance nyo. Okay, so ano ba to? Okay. So ang wala ngayon si Villaluna, no? Wala pa rin. Okay. Pumapasok ba ba to, Mr. Nana, Carlo, Rafael? Si Villaluna? Christine May? Andiyan ba kay class? Hello?
Yes po, sir.
Pumapasok pa to si Miss Christine Villaluna?
Sa class yung subject ko po, sir, hindi ko po ako naging present na. Pero sa mga test teams po namin active.
Okay. Okay, so yun po, Tapos pagkatapos sa final exam ninyo class, sa mga self-review, okay, di-disable ko na wala na akong i-accept na any responses na magagaling sa inyo. Okay? So, alam ko mga estudyante, hindi nawawalan ng excuses. Okay? Hindi maubusan. Okay? So, yun po.
Sir,
Question class.
yun lang po.
Yes po.
Bali po, next week na po yung finals namin. Then,
si Tina.
wait lang po, sir.
Yes. Bende. Ano po yun?
So, bali po, isa-send po yung self-review para po sa finals. And then, next week, Saturday po yung finals.
Opo. Opo. Itong self-review, kagaya sa dalawang papadala ko sa inyo, no? Para sa
Yes po, yes.
data comms
Sa classroom na lang
and
po
sa
isa-send.
operating system. Opo, sa Google Classroom.
Okay po, thank you po.
Pero bago yun, no? I-update ko kayo sa update ko kayo sa GC. Okay?
Okay po.
Para
Thank you po.
at least dalawa, no? Ikaso pumalya doon sa Google, at least meron kayong backup na GC. Okay. Any other question class? Any suggestions class? Tapos na ang klase nating class, ha? Tapos na po. Baka meron po kayong suggest or questions. May ID na ba kayo lahat?